Now let us talk about achievements of Mendeleev's periodic table. While developing the periodic table, there were some places where Mendeleev kept element with greater atomic mass before and a slightly lower atomic mass element afterwards. As we all know that when he kept these elements in the periodic table, he observed that they were arranged in increasing order of their atomic masses. But somewhere, some places, he observed that the element which is has slightly greater mass, that was first, and the element which has slightly lower mass than the other was kept afterwards. So let us see in this periodic table where it is. It is cobalt and nickel. Cobalt has atomic mass 58.9 and nickel has atomic mass that is 58.69, that is nearly equal to 58.7. Now which is greater, 58.9 or 58.7? Obviously 58.9. Then also this cobalt is placed before nickel. This was done because the sequence was inverted, so that the elements with similar properties could be kept together. So, for the reason that the elements must be kept together with similar properties, this was done. The next achievement, if we see, Mendeleev left some gaps in between this periodic table. If there are spaces, gaps between these elements, one can think that it is defect. But Mendeleev boldly said and he predicted that some elements which are not yet discovered, that will be fixed in these gaps. And he said that the properties of that elements will be similar in which they are kept, in which group they are kept. So he boldly predicted that there will be elements which will be placed in these gaps. So this way he kept gaps. And he predicted their names by a prefix in a Sanskrit numeral, that is Eka. Eka means 1. And for which elements did he discover this? Here is the table. Eka boron. He gave this name, Eka boron. And the element which was discovered later on, that is replaced by this Eka boron, was scandium. Which means when Mendeleev prepared this periodic table, that time he gave this with word Eka. Eka boron. Why did he say Eka boron? Which means it will have similar properties to boron. And the elements which was discovered later, that was scandium. Similarly, he gave one another name, that is Eka aluminium, which means the element which we'll discover later that will have similar properties to aluminium, and that is gallium. Then Eka silicon, and the element which was having similar property to this, that was germanium. So what he predicted, that way the elements to kept in the gaps were discovered. So in this table also we can see property Eka aluminium and gallium. Here atomic mass of Eka aluminium, that is 68 and gallium as 69.7. Formula of oxides and chlorides are given. And because of this correct discovery, the correctness and usefulness of Mendeleev's periodic table was convinced. And because of this success of Mendeleev's periodic table, people recognized him as the originator of the concept on which it is based. Noble gases like helium, neon, argon, these noble gases have been mentioned in many contexts before this. Now, what are noble gases? We all know, right, that they are colorless, odorless, tasteless. So, these are their physical properties. And if we talk about chemical properties of noble gases, they are least reactive elements, which means they do not react quickly, they are least reactive. So these noble gases were discovered very late because they are inert and they are present in very low concentration, extremely low concentration in our atmosphere. One more advantage of Mendeleev periodic table is that when these noble gases were discovered, they could be placed in a new group. So whole group was new of noble gases without disturbing the other elements order. So these all are the achievements of Mendeleev's periodic table. Now let us talk about limitations of Mendeleev's classification. Electronic configuration of hydrogen that resembles that of alkali metals. Like alkali metals, hydrogen combines with halogens, oxygen and sulfur to form compounds which have similar formula as shown in the table. What are halogens? When we'll study the modern periodic table, that time we will learn that group number 17 is known as group of halogens. So that elements are known as halogens. They are non-metals. So here compounds of hydrogen, that we can say that it forms compound with chlorine, oxygen, sulfur. Similarly, compounds of sodium, there also we can see compounds with chlorine, oxygen and sulfur. So this way hydrogen combines with halogens. Here it is chlorine, then oxygen also with sulfur as we can see in the table. So this way can see the elements of group number 17 which are known as halogens. So fluorine, chlorine, bromine, iodine, this all are called halogens. One more limitation of Mendeleev's periodic table is that there was no fixed position of hydrogen in the periodic table. So this is the first limitation of Mendeleev's periodic table, which will remember what it is. There was no fixed position given to hydrogen in the Mendeleev's periodic table. He could not assign a correct position to hydrogen in his table. Then the next is isotopes were discovered long after Mendeleev has proposed his periodic classification of elements. What are isotopes? We have already learned, right? The elements which have same atomic number but different atomic mass. Okay, atomic number is what? Number of protons, and atomic mass is what? Number of protons plus number of neutrons, which means the elements will have same number of protons but different number of neutrons. We have learned isotopes of hydrogen in standard 9. What are they? Protium, deuterium and tritium. Let us see one more example, and that is of chlorine. Chlorine 35 and chlorine 37, C35 and C37. These two are isotopes. How? Because in chlorine 35 and 37 number of protons are similar, 17, but in chlorine 35 18 neutrons are there, whereas in chlorine 37 20 neutrons are there. So this you need to remember. So isotopes of all elements posed a challenge to Mendeleev's periodic law, because in this they were not mentioned. They were discovered late after Mendeleev's periodic table. Then another limitation of Mendeleev's periodic table is that atomic masses do not increase in a regular manner in going from one element to the next. What it is? For every element, it was not like that every time atomic masses were increased. So that was another limitation. So it was not possible to predict how many elements could be discovered between two elements. Okay, because we don't know that every time the atomic masses will increase or not. So it was another problem, that it was difficult to predict how many elements could be discovered in between two elements, especially when we talk about the heavier elements. So these all are limitations of Mendeleev's periodic table.